Let's talk about effective nuclear charge. How can we calculate that for an electron in an atom? Well, let's start with this problem. What is the effective nuclear charge for an electron in the n equal 2 shell, let's say in an atom of fluorine? Well, the first thing we're going to do is draw a picture. Now, hopefully you have a periodic table with you. You want to determine the atomic number of fluorine. The atomic number of fluorine is 9. So this tells us that fluorine has 9 protons in its nucleus. In the first energy level, there are 2 electrons. These are known as core electrons. And in the second energy level of fluorine, there's 7. Keep in mind, atoms have equal number of protons and electrons. So the number of protons in fluorine is 9, represented by the symbol Z. So an atom, which is electrically neutral, will have 9 protons and 9 electrons. The first shell can hold 2 electrons, so the second shell has to have 7, because 2 plus 7 is 9. So now, our goal is to find the effective nuclear charge of one of these electrons. By the way, the electrons in the outermost energy level, what are they called? These electrons are known as valence electrons. To calculate the effective nuclear charge, this is the simplified way. It's equal to the number of protons in the nucleus, Z, minus the number of inner shell electrons, or core electrons. So there's 9 protons in the nucleus, that's the atomic number, and there's only 2 inner shell electrons with respect to this one. So those 2 electrons that I've just highlighted here, they shield this electron from the nucleus, thus reducing the effective nuclear charge. So it's 9 minus 2, which is 7. So that is the effective nuclear charge on an n equal 2 electron. Now, the n equal 1 electron, their effective nuclear charge is about 9, because there's no other electrons between this electron and the nucleus. So they feel the greatest nuclear charge because they're so close to the nucleus. Now, let's move on to our second example. What is the effective nuclear charge for an electron in the n equal 3 shell in an atom of aluminum? Now, if you want to try this problem, feel free. Go ahead and pause the video and see if you can get this one. So keep in mind the formula for the effective nuclear charge is the atomic number minus the number of inner shell electrons. So what is the atomic number of aluminum? The atomic number of aluminum is 13. So if you go to the periodic table, you'll see 13 above aluminum and 26.98 below it. 26.98 is the mass number. This is the atomic number. It's a whole number, and it's the smaller of these 2 numbers. So that's where you could find it in the periodic table. So there's 13 protons in the nucleus of an aluminum atom. Now, in the first shell, there's always going to be 2 electrons. The second shell can hold a maximum of 8 electrons. So right now we have a total of 10 electrons, but we need to get to 13. An atom of aluminum has 13 protons and 13 electrons. So keep that in mind. For atoms, the number of protons and electrons are the same. But for ions, which possess a charge, the number of protons and electrons are different. So now let's put the last 3 electrons in the outermost energy level. So what is the effective nuclear charge for, let's say, this electron, which is in the 3rd energy level? So it's 13 minus S. So how many inner shell electrons do we have? We have 2 in the first shell, 8 in the second shell, so we have a total of 10 electrons that exist between the nucleus and this one. So there's 10 inner shell electrons. So it's going to be 13 minus 10, which is 3. So that is the effective nuclear charge for an outermost electron in aluminum in the N equals 3 shell. Now let's work on one more example for the sake of practice. What is the effective nuclear charge, let's say for an electron in an atom of chlorine in the third shell? So let's begin with the formula. Now what is the atomic number of chlorine? Chlorine has an atomic number of 17, and so there's 17 protons in its nucleus. The first shell has 2 electrons, and the second shell, just like aluminum, has 8 electrons. Now the third shell, the last shell, has the remaining 7 electrons. So those are the 7 valence electrons in chlorine. So now let's finish this problem. So we have an atomic number of 17, and for an N equals 3 electron, we see that there's 10 inner shell electrons. 2 in the first, 8 in the second. So the effective nuclear charge is plus 7. And notice that this is equal to the number of valence electrons in a chlorine atom. When dealing with representative elements in, let's say, groups 1, 2, or 3 to 8, if you're looking for the effective nuclear charge of a valence electron, it's the same as the group number.